Alright, so this is a revised video of one part of the first discussion about the evolution. So this is the records of life. So what do we have right here? So we will try to find out or how radioactive radiometric dating finds out the age of fossils and rocks that are unearthed by some geologists or paleontologists. So what do we have right here? So I will just include in this discussion how is the computation or what is the process done, all right, in order to compute the exact age of the particular rock or fossil. All right, so in the radiometric dating, as I said earlier, this is a technique in using radioactive isotopes in determining the age of rocks and fossils. So common isotopes here is the carbon-14. So we called it the carbon dating. So most organisms are made up of carbon, and this carbon-12, all right, so this carbon-14 will become carbon-12 and become nitrogen in the future run. So there you go. So as the number of protons, as the number of protons in this particular isotopes decrease, it transforms to become a new element. So if you trace down the periodic table, so what is next? What is before carbon? We have nitrogen. So there you go. So its mass becomes less and less. So that loss in mass is what they call your half-life. Alright, so that's what they call your half-life. So in this case, half of the carbon-14 will decay around 5,730 years. So ibig sabihin, or in this case, in this case that the carbon-14 will become a nitrogen. So carbon-14 will become a nitrogen after 5,730 years. So after that one, after 5,730 years, it will become a nitrogen. Alright, so it will be compared to carbon-12 counterpart to look for its ratio, how many years the organism have died. Alright, so in this question, your measurement indicate that a fossilized skull you unearthed has carbon-14 to carbon-12 ratio for about 1/16 that of the atmosphere. What is the approximate age of the skull? Alright, so based on this idea, the decay of the carbon-14 will become the decay of the carbon-14 to become nitrogen for every 5,730 years. Then after 5,730 years, it will become another new element. So again, 5,730 years, it will become a new element. So new element. So now, what's the answer to this? What's the answer? So just ignore my first answer here. I miscalculated that one. So 1/16. So let's take a look at this graph. Alright, so this is the original amount of your carbon-14. Now, as it decays, so one half of the content of that original number of carbon, and one half of the original content, so it happens, half of its content happens 1 year. And so that is its half-life, so 1 year. Next one, one fourth of its content, and 1/4 of its content in 2 years. Then 1/8 or 1/8 of its content in 3 years. So if this is 1/16, so if we will continue this graph forward, so meaning to say that the 1/16 is probably 4 years. Alright, so 4 years. Its half-life is 4 years. Okay, so with that, alright, so 1/16 of its content. So meaning to say that that your carbon over here will become carbon-12, and then the idea that the carbon becomes every 5,730 years, it becomes it's what they called half-life. So one half of it. Alright, so that's one half of it. So it will transform to become a new element somehow. Then the thing here is, if the 1/16 is equivalent to 4 half-lives, 4 years. Then therefore, what do we have right here? So 4 times 5,730 years. That is around 22. Alright, 22 in my calculation. So 5,730 times 22, or rather times 4. That is around 22,920 years. So meaning to say, it took 22,920 years for the carbon to become carbon 12. Alright, it took to 22,920 years for the carbon to become carbon 12. So this is its half-life, 4 years. Then after that one, yan, so multiply it to the standard number of years the carbon transformed to become a new element, like nitrogen. So that's how carbon dating works. And as I said earlier, as I said on the first video, that not only carbon can be used for carbon dating. We have lots of elements or lots of isotopes that can be used in this radiometric dating. So with that, with this particular concept, I hope you will be able to understand how radiometric dating works. Alright, so that's it. Goodbye and God bless.